Hello friends, today we will continue remaining part of lesson number 2, that is polynomial. Relationship between zeros and coefficients of a polynomial. See, if ax square plus bx plus c is any quadratic polynomial. We will focus on quadratic polynomial only. So ax square plus bx plus c is any quadratic polynomial, and alpha and beta are the zeros. Then the relation is alpha plus beta, that is sum of zeros, is equals to minus coefficient of x upon coefficient of x square, that is minus, what is the coefficient of x here? We can see it is b, so minus b upon a. So this is sum of the zeros. This is first relation between coefficients and zeros of the quadratic polynomial. And one more relation is alpha into beta, that is product of zeros, is equals to constant term divided by upon coefficient of x square. What is constant term? C upon a is one more relation, that is alpha dot beta is equals to c upon a. So based on these two relations, we will see exercise 2.2, where we need to find the zeros of quadratic polynomial and we need to verify the relationship between coefficients and zeros of the quadratic polynomial. This is one point. One more point is how to form quadratic polynomial if zeros are given. If zeros are given, then we can find out the quadratic polynomial by using one formula which we will see now. If alpha and beta are the zeros of a quadratic polynomial, then जर अल्फा आणि बीटा हे जर झिरोज असतील तर आपल्याला क्वाड्रॅटिक पॉलिनॉमियल फाइंड आउट करायचे. या एक्सरसाइज मध्ये दोन महत्त्वाचे पॉइंट, टू इम्पॉर्टंट पॉइंट्स, दॅट इज फर्स्ट इज if the quadratic polynomial is given, then we can find out the zeros of the polynomial. And second point is, if zeros are given, then we can find out the quadratic polynomial. If alpha and beta are the zeros of a quadratic polynomial, then required quadratic polynomial is k is any real number into x square minus sum of the zeros alpha plus beta into x plus product of zeros alpha beta. So this is our required quadratic polynomial. If alpha and beta zeros are given, alpha and beta are the zeros, then we can find out the quadratic polynomial by using this relation k into bracket x square minus alpha plus beta into x plus alpha beta. K is any real number which is multiplied to the quadratic polynomial. Why this is k there? Because see, any quadratic polynomial, if alpha and beta are the zeros of quadratic polynomial ax square plus bx plus c, then if you multiply this polynomial by any number k, the zeros are same. So if the zeros are given, there are infinite number of quadratic polynomial which can be multiplies or multiples of this polynomial. If we multiply any quadratic polynomial by any real number, we will get a new quadratic polynomial, but the zeros of the quadratic polynomial are same. तेच झिरो असणारे आपण असंख्य क्वाड्रेटिक पॉलिनॉमियल तयार करू शकतो. सो दीज आर द 2 पॉइंट्स which we will solve in exercise 2.2. So we will start exercise 2.2. Exercise 2.2. Question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Now the sub question is first is x square minus 2x minus 8. See, this is a quadratic polynomial which is trinomial also. In such cases, we can find out the zeros by splitting the middle term. Here, the first step is, पहिल्यांदा तुम्हाला दिलेली क्वाड्रेटिक पॉलिनॉमियल झिरो बरोबर इक्वेट करावी लागेल, कारण या पॉलिनॉमियलची x ची कुठली व्हॅल्यू ठेवल्यानंतर आपल्याला या पॉलिनॉमियलची व्हॅल्यू झिरो बनणार आहे. and that's why we need to equate this polynomial with 0. So first step is x square minus 2x minus 8 is equals to 0. Now when there is a quadratic polynomial which is a trinomial like this is in the form of ax square plus bx plus c. A is 1, b is equals to minus 2 and c is equals to minus 8. Now you can find out the zeros by splitting the middle term. What is to be done for splitting the middle term? C into a. So minus 8 into 1. We need to write here rough minus 8. Minus 8 into 1. C into 1. And split this minus 8 into 2 terms so that the sum of the splitting must be equal to the b, that is coefficient of x, which has to be minus 2. Now if we have two alternatives here. We can write 4 into 2 or 8 into 1, but always remember the bigger splitting must be given sign of middle term. So we need to give minus here or here, and look at the sign of this product, it is negative. So the product of positive and negative is negative. That's why plus 2 has to be given positive sign and plus 1 has to be given positive sign. But the horizontal sum minus 8 plus 1 will give you minus 7. So I need minus 2. So that's why this splitting is wrong. But here minus 4 plus 2 will give you horizontal sum minus 2, which is equals to coefficient of x, that is b. That's why this splitting is correct. Now if we practice more and more, you can directly write the splitting minus 4 plus 2. Now by using this splitting, we can write 4 terms instead of 3 terms. X square minus 4x plus 2x minus 8 is equals to 0. 3 टर्म्स मधून आपण 4 टर्म्स बनवल्या का? कारण आपल्याला कॉमन काढून त्याचे फॅक्टर्स पाडता आले पाहिजेत. फ्रॉम दिस फर्स्ट अँड 2 अँड थर्ड अँड फोर्थ टेक द कॉमन. हिअर कॉमन इज x. whatever is balance inside the bracket is x square मधून x कॉमन काढले x minus 4x मधून x कॉमन आले 4. here there is no common variable but 2 आणि 8 मध्ये मात्र plus 2 common आहे. so plus 2 common, x minus 2 4 is 8 is equals to 0. While solving such examples by splitting the middle term, these two bracket has to be same, otherwise something is wrong. So now next step is take this x minus 4 common and this x and this plus 2 in the other bracket is equals to 0. Now this step shows us that product of two brackets is 0. That means either of the bracket must be 0. Therefore x minus 4 is equals to 0 comma x plus 2 is equals to 0. Therefore x is equals to 4 comma x is equals to minus 2 are the zeros of given quadratic polynomial. So this will give you 1.5 mark, and the remaining solution, that is verify the relationship verify करण्यासाठी आपल्याला 1.5 मार्क आहे. so this question is for 3 marks. now let us assume that these zeros are alpha and beta. so let one zero is alpha, so alpha is equals to 4 and another zero, दूसरा zero ला आपण beta म्हणूया, beta is equals to minus 2. now as we need to find the relationship or verify the relationship between coefficients and zeros, we need to write the coefficients. so compare given polynomial with standard form. Comparing given polynomial with ax square plus bx plus c. what is a? A is equals to 1. what is b? B is equals to minus 2 and c is equals to minus 8. now we can verify the relationship. I can write verification. how to verify? you know alpha and beta. alpha is 4 and beta is minus 2, so you can find out the alpha plus beta directly. alpha plus beta is equals to 4 plus minus 2 will give you 2 by relation alpha plus beta. what is the relation? minus coefficient of x. so formula madla minus and b is minus 2. upon a is 1 So minus inside the bracket again minus will become plus. So 2 upon 1. So 2. Here actual sum is 2 and by relation the sum is also 2. So alpha plus beta relation is verified. One more relation, and alpha into beta is equals to 4 into minus 2 will give you minus 8. By relation alpha dot beta, that is alpha into beta, is equals to C upon A. C is minus 8. Minus 8 upon 1, which is equals to minus 8. So sum is verified. Product of zeros also verified. So verified. So this will give you 3 marks. This is the question for 3 marks. We will solve question number 2, sub question 2. Sub question 2. 4s square, variable is s. 4s square minus 4s plus 1. So first step is, पहिली step same, equate this polynomial with 0 because it is a trinomial and which is quadratic polynomial. We need to split the middle term. We can find the zeros by using splitting the middle term. So this is C, this is B, and this is A. So first equate it. 4s square minus 4s plus 1 is equals to 0. So write C into A, that is 1 into 4 plus 4. Split it. I need horizontal sum has to be middle coefficient of middle term, that is minus 4. So minus 4 येण्यासाठी I can write 2 into 2. So middle term चा sign minus, product चा sign plus आहे. So negative negative चा product positive. So that's why minus 2 into minus 2, the product is positive 4 and the horizontal sum is minus 2 minus 2 is minus 4, which is equals to the coefficient of middle term. So this splitting is correct. Now we can convert 3 terms into 4 terms. 4s square minus 2s minus 2s plus 1 is equals to 0. Take common from these two. Common from these two. Here 4 आणि 2 मध्ये 2 कॉमन, व्हेरिएबल मधून s कॉमन. So 4 divided by 2 is 2. Whatever the common, we need to divide each term by the common. So 4 divided by 2 and the remaining part is in the bracket. So it is 2 minus 2s divided by 2s will give you 1. 2s minus 1. Here there is no common. When there is no common, take 1 as a common along with sign minus 1. Bracket मध्ये negative divided by negative will positive 2s and plus 1 divided by minus 1 is minus 1 is equals to 0. Now look at the two brackets. Two brackets are same. So we are correct. So we can take 2s minus 1 again common. 2s minus 1 and this 2s and minus 1 into another bracket. 2s minus 1 is equals to 0. 2s minus 1 is equals to 0 or 2s minus 1 is equals to 0. Therefore 2s is equals to 1 or नाही लिहिलं तरी चालेल कॉमा. 2s is equals to 1. s is equals to 1 upon 2. s is equals to 1 upon 2. are the zeros. Now let alpha is equals to 1 upon 2 and beta is equals to 1 upon 2. Compare the given polynomial with standard form. You will get a is equals to 4, b is equals to minus 4 and c is equals to 1. Now the verification is alpha plus beta. Alpha plus beta will give you actual sum 1 upon 2 plus 1 upon 2 is equals to 2 upon 2, which is equals to 1. And by relation, what is the relation? Alpha plus beta is minus b upon a. So minus, what is b here? Again minus 4, minus 4 upon 4 will be 4 upon 4, which is equals to 1. And product alpha into beta, 1 upon 2 into 1 upon 2, this is actual, product is 1 upon 4. And by relation, c upon a, alpha dot beta, alpha into beta, that is product of zeros is c upon a. What is c here? 1 and a is 4. So 1 upon 4. So product is verified, sum is also verified, so relation is verified. So this is how question number 2, sub question 2. Now we will solve question number 3. What is question number sub question 3? 6x square minus 3, 6x square minus 3 minus 7x. ऑर्डर थोड़ी जम्बल्ड आहे. वी नीड टू राइट इन प्रॉपर ऑर्डर. 7x फर्स्ट and minus 3 last. So 6x square minus 7x minus 3 is equals to 0. A is 6, B is minus 7 and C is minus 3. So C into A, 3 into 6, 18, but minus 3, so minus 18. Split the minus 18 to get horizontal sum minus 7. So I can write 9 into 2. So middle term sign is for bigger splitting. To get the product negative, plus 2 and horizontal sum is minus 9 plus 2 is minus 7. So our splitting is correct. Therefore it can be converted into 4 terms. 6x square minus 9x plus 2x minus 3 is equals to 0. Take the common from first two, common from third and fourth. So here 6 and 9 is divisible by 3. So 3 common and variable madun x common. So 3x is common. Whatever is the common, divide every term with the common. So 6 divided by 3, 2, and x square divided by x will get x, and 3 3 is a 9, x cancel, so 2x minus 3. Here there is no common, so take common 1 along with sign plus 1, and there is no change inside the bracket is equals to 0. So two same bracket, write once, 2x minus 3, 3x plus 1 is equals to 0. Therefore 2x minus 3 is equals to 0, 3x plus 1 is equals to 0, 2x is equals to 3, 3x is equals to minus 1. Therefore x is equals to 3 upon 2 and x is equals to minus 1 upon 3 are the zeros. let alpha is equals to 3 upon 2, beta is equals to minus 1 upon 3. Comparing given polynomial with standard form, a is equals to 6, b is equals to minus 7, and c is equals to minus 3. Now actual sum alpha plus beta is 3 upon 2 minus 1 upon 3. 3 upon 2 minus 1 upon 3. Cross multiplication, 3 2 is 6, 3 3 is 9, minus 2 will be 7 upon 6. By relation, minus b upon a. So minus and b is also minus. So minus 7 upon a is 6. So minus becomes plus. So 7 upon 6. Addition sum is verified. Product is 3 upon 2 into minus 1 upon 3 will give you 3 get cancelled. So minus 1 upon 2. And by relation, c upon a. What is c? C is minus 3 upon 6. By reduction, we can write 3 1s and 3 2s. So minus 1 upon 2. Again, the product is also verified. So hence, relation between zeros of the polynomial and constant term are verified. So this is sub question 3. Now we will solve sub question number 4. Sub question number 4. 4u square plus 8u. So see, this is a quadratic polynomial, but this is not a quadratic trinomial. Trinomial नाही आहे. So अशा वेळेस मग आपण दुसरा पर्याय शोधायचा. Is there any common? Yes, 4u is common. Or if we can use the identity a square minus b square, that is also to be seen. So here we can take the common. So first step is same. Compare given polynomial with 0. Equate it with 0. Take the common. 4u is common. So here 4 and 4u square madun 4u common. Only u is balance. And 4 to the 8 2 and u is common. So is equals to 0. So I can write 4u into bracket is equals to 0. That means 4u is equals to 0 or u plus 2 is equals to 0. So u is equals to 0 upon 4 and u is equals to minus 2. Therefore u is equals to 0. 0 upon anything is 0 and u is equals to minus 2 are the zeros. Let alpha is equals to 0 and beta is equals to minus 2. One 0 is alpha and another 0 is beta, so that is minus 2. Now if we want to compare this polynomial, here square term, it is 8u, variable with coefficient 8. There is no constant term, so we can write constant as 0. So a is 4, b is 8 and c is 0. Again alpha plus beta is 0 plus minus 2, that is 0 minus 2. Alpha plus beta is 0 minus 2 will give you minus 2. By relation, minus b upon a. What is b here? 8. So minus b 8 upon 4. A is 4. So 4 ones and 4 twos are so minus 2. So sum of the zeros is verified. Product of zeros, 0 into minus 2, 0 into anything is 0. By relation I can write C is alpha dot beta is C upon A. So C is 0, 0 upon 4, which is again 0. So product is also verified, hence the relation is verified. Very simple. So again, every question in this question, main question, all sub questions are for 3 marks each. Now sub question number 5. T square minus 15. T square minus 15. See, this is again a quadratic polynomial, but it is not a trinomial. And again there is no common variable here. Here there is t, but here there is no t. So it is a different question. Here we need to use the identity a square minus b square is equals to a plus b, second bracket a minus b. So first compare or equate it with 0. See, 15 is not a square of any whole number, but we can write 15 as root 15 square. So t square minus root 15 square. Now we got the polynomial in the form of a square minus b square. A is nothing but t and b is nothing but root 15. For your convenience, you can write using a square minus b square identity, first bracket a plus b, second bracket a minus b. So a is t, which is equals to, therefore a is nothing but t, t plus root 15, t minus root 15 is equals to 0. So t plus root 15 is equals to 0, comma t minus root 15 is equals to 0. So t is equals to minus root 15, t is equals to plus root 15. So alpha is equals to minus root 15 and beta is equals to root 15 are the zeros. Okay. Now here constant is minus 15. So c ची व्हॅल्यू आहे आपल्याकडं, b ची नाहीये. So you can take b as 0, a 1. So t square चा कोएफिशिएंट 1 आहे. So 1, b is 0 and c is minus 15. Now verify the relationship. Alpha plus beta, that is minus root 15 plus root 15. So minus root 15 plus root 15 will be 0, and by relation alpha plus beta is minus b upon a. What is b here? b is 0. 0 upon a is 1. 0 upon anything is 0. So sum of the zeros is verified. Alpha plus beta, actually minus root 15 into root 15. So root 15 into root 15 is 15, but the sign is minus, and c upon a is, what is c here? Minus 15. And what is a? 1, which is again minus 15. So product is also verified. So relation is verified. So this is sub question number 5. Very simple questions. If you practice, more and more times you will be very much friendly with all these questions. Now last question, 3x square minus x minus 4. Last sub question, 3x square minus x minus 4. First equate it with 0. 3x square minus x minus 4 is equals to 0. A is 3, B is minus 1 and C is minus 4. So minus 4 into 3 is minus 12. minus 12 चं splitting करायचं आहे, so that I should get minus 1 as a horizontal sum. So 4 into 3, middle term चं sign bigger splitting ला. So always remember bigger splitting has to be given middle term sign. So middle term sign is minus, and to give the sign for 3 we need to look at this sign. The product is negative and we know the product of negative and positive is negative, so 3 has to be given plus sign, and the horizontal sum we will get minus 4 plus 3 is minus 1. This is how we can split the 12. So next step is 3x square minus 4x plus 3x minus 4 is equals to 0. Take the common. Here there is no common between 3 and 4, only x is the common. So whatever is the balance, 3x square madhun x common, 3x and minus only 4 is remaining. Here there is no common, so take one common with along with plus sign, and 3x minus 4 is equals to 0. Now the same bracket once, 3x minus 4, x plus 1 is equals to 0, 3x minus 4 is equals to 0, x plus 1 is equals to 0, 3x is equals to plus 4, x is equals to minus 1, so x is equals to 4 upon 3, x is equals to minus 1 are the zeros. So let alpha is equals to 4 upon 3 and beta is equals to minus 1. Compare the given polynomial with standard form. We will get a is equals to 3, b is equals to minus 1 and c is equals to minus 4. Now verification. Actual sum alpha plus beta, 4 upon 3 minus 1, 4 upon 3 minus 1 upon 1. So cross multiplication, it is 3, 1 4 is a 4, minus 3 1 is a 3. This is cross multiplication. You will get 1 upon 3. By relation, b is minus 1. Look at this. Here minus and b is again minus 1 upon a is 3. So minus and bracket madhe minus becomes plus 1 upon 3. So sum is verified. Now the actual product is 4 upon 3 alpha into beta काय आहे minus 1. So it will be minus 4 upon 3. By relation, c is minus 4 and a is 3, so minus 4 upon 3. Again the product is also verified, so relation is verified. So this ends main question 1, in which we have solved sub questions 1 2 3 4 5 and 6. One more question in this exercise, main question 2, in which zeros are given, or sum of the zeros and product of the zeros is given, we need to create or we need to form the quadratic equation from the given zeros, or maybe from sum of the zeros and product of the zeros. We have discussed how to form the quadratic polynomial. We will solve question number 2 in next period. Till then, bye bye. Thank you.